we are going to divide 2x cubed plus 5x squared plus 4x minus 4 by x minus 2. Alright, so when we do this, remember yesterday we said your polynomial had to be in standard form and you had to have every exponent accounted for. So we double check we have a 3, a 2, a 1, a 0. We can set up long division. So let's see, rewrite this down. 2x cubed plus 5x squared plus 4x minus 4. Alright, now yesterday, when we talked about long division, we said the first thing you do is you always look at the first term under the long division bar, and you look at the x. You always compare or divide by the x. The 2 will come later. So we have 2x cubed divided by x. 2x. So we put 2x on the top. And then, so I take 2x times x, which is 2x cubed. Remember, those always need to be the same. And then 2x times negative 2 is negative 4x. So I have negative 4x here. What? Did I mess up? Yeah, I don't know what I did. You're right. Yeah, this should be a square on the top. I feel like we need to start over. 2x squared. All right, now 2x squared times x is 2x cubed. There we go. I've got it. I know what I'm doing. 2x squared times negative 2 is negative 4x squared. Good. Now then we said the biggest thing was to put parentheses and a minus. And the first two always cancel. Right? That's a rule. What is 5 minus negative 4? 9x squared. Good. And then I bring down the 4x. Then I start over. 9x squared divided by x is 9x. I multiply the 9x times x minus 2. So we'll get 9x squared and minus 18x. Parentheses and a minus. Well, those 9x squares cancel, like usual. Yeah, 22. 4 minus negative 18 is 22x. And I bring down the last term of negative 4. Alright, 22 divided by x is 22. 22 times x is 22x. And 22 times negative 2 is minus 44. Parentheses, minus. We cancel. Negative 4 minus negative 44. 40. Positive 40. Negative 4 plus 44. So that's our remainder. So how would you write your final answer? I'll just write it up here. Yeah. Plus 22.
Plus 40 over x.
Yeah. So when you write your remainder, you write the number over the x minus. Now we'll come back and we'll fill in that synthetic division box in just a second. But let's get a definition in here. Synthetic division is a simpler process for dividing a polynomial. And a polynomial, remember, means many terms. So we're dividing something with many terms by a binomial. And a binomial has 2 terms. Alright, so synthetic division is really nice and it's really helpful, but it's only helpful in a very specific situation. In order to use synthetic division, the divisor, and the divisor is the thing you're dividing by, has to be in this format. X, and we're going to say plus or minus a. So all that means is it's x plus a number or x minus a number, like x plus 7 or x minus 2. The coefficient on the x has to be a 1. So you can't divide by x squared, you can't divide by 3x. It has to be just x plus something. So that's the only limitation on synthetic division. The dividend, the thing you start with, the original polynomial, has to be in standard form, just like long division. All right, so you have to have zeros as placeholders. synthetic division actually looks like here. So we'll go right back up to the top. So what synthetic division looks like is instead of doing our division bar right side up like this, we actually end up kind of doing an upside down division bar. Right? So it's like a little box. Now, along the top of the box, kind of floating, we're going to put a row of numbers. We're going to leave a space because we're going to write inside the box. But along the top of the box, we write the coefficients from the dividend, what we start with. So we write a 2, right, and leave some space underneath. The next coefficient is a 5, and then a 4, and the last one is a negative 4. Okay, so those go along the top. Then outside of the box, we're going to put what we're dividing by. Well, we're dividing by x minus 2. Now, however, we're not going to write x minus 2 out the front. Our goal, remember with division, is to decide if x minus 2 is a factor, right? So if we could factor out x minus 2 from the polynomial. That also means that we're testing to see if x equals positive 2 is a root, right? If x minus 2 is a factor, then x equals positive 2 will be an x-intercept. So we actually put the positive root that we're looking for out in front. All right, now follow the process here. Once you get it, it'll go really fast. Start the first time by just bringing down the 2 and putting it underneath. Now what you're going to do with that 2 is you're going to multiply 2 times the 2 out in front, which is 4. It goes in the space. And it's 5. What you're going to do is you're going to add those together. 5 plus 4 is 9. Multiply again. 9 times 2, 18. Add up together and you get. Are you remembering some of these numbers from the previous problem?
How does a real
22 times 2 is 44, and negative 4 plus 44 is 40. Now, I put the last number, I like to put it in its own little box. That number here is the remainder. The last number you get is the remainder. Now, what happens, what do you notice about the 2, 9, and the 22, and the 40 from the original? Those are the same numbers. So when we divide a polynomial, we started with x cubed, and we divided it by an x. So what should be, if this is a coefficient, what should be the exponent on the x after this? X squared. I started with the cube. I divided by x, which means it lowered the exponent by 1. So this is 2x squared plus 9x plus 22. And we had a positive remainder of 40 over x minus 2. Did we get the same answer? This process was easier. A little synthetic, right? A little bit faster. Okay, so let's do a couple. Let's make sure we understand the process, but yes. Yes, and we'll see one like that in a minute. Good, all right, let's pop down to the bottom. All right, now we double check that we're in standard form. I have a 3, a 2, a 1, a 0. I'm in standard form. I have all my places. So let's jump right to synthetic division. You write your upside down little box. You write the coefficients from the dividend along the top. So a 5, a negative 2, a 5, and a positive 2. What do I write on the outside? What am I trying to see as a root? Positive 4. Yep. All right, so the process is going to be the same. I bring down the 5. 5 times 4 is 20, not 40. I don't know where I got 4 from. 20. And I add those together, which gives me 18. Might need a calculator here. 18 times 4. 72, yeah. Add those up. Get 77. And I have 77 times 4. Let's see, 308, yeah. Add those up and I get 310, and that's my last number, so I put in a little box. So I know that it's the remainder. Now I have to turn my into a polynomial. The numbers themselves don't mean anything. So when I write this, if I started with x cubed, what would be the exponent on the 5 here? X squared. So 5x squared plus 18x plus 77. Now I have a remainder plus 310 over x minus 4. Now since I have a remainder, is the divisor a factor? No. Let's try the next one. We don't have that many today. All right, next one here. So I start with my upside down box. I have all my exponents. I have a 4, 3, 2, 1, 0. What's the coefficient that I write down for x to the 4th? 1. Ooh, there's a 1 there. You only put 0 if there's no exponent. 1, then a 2, then a 1, negative 12. All right, and what am I putting out in front? X equals negative 2, the opposite. Okay, this time I bring down a 1. 1 times negative 2 is negative 2. When I add those up, what do I get? 0. 0 times negative 2 is 0. And I add and get 1. 1 times negative 2 is negative 2. I get a negative 6 here. And negative 6 times negative 2 is 12. When I add them, what's my remainder? 0. That's a good thing because if my remainder is 0, is x plus 2 a divisor? Or a factor? Yes. All right, so let's write our final answer. I started with x to the 4th. So this would be 1x cubed. Do I have to write an x squared if there's a 0? No. Plus 1x minus 6. You could put plus 0x squared in there, but you don't. All right, flip it over, and then we'll do kind of something. We'll tie it back to something old here after we do this one. 3x cubed plus x squared minus 4 divided by x minus 1. Do I have all of my exponents? Not this time. So I'm going to need to put a placeholder in. So I have a cubed. I put the 3. I have a squared. I don't have an x, so what placeholder will I have to fill in? 0, and then a minus 4. So it's going to be the same way. I take the opposite of the factor, x equals 1. And here I'll bring down the 3. 3 times 1 is 3. Okay, 4 when I add. 4 times 1 is 4. Add those. And then 4 times 1 is 4. What's my remainder? 0. So we will be a factor. We just have to write our answer. 3x squared plus 4x plus 4. So this next problem we're going to do, we only have one more to do today, has, excuse me, it's tying back to the last unit, and it's kind of a preview of what we're going to be using this long and synthetic division for coming up later on. Oh, there's this one too. Well, that's okay. We can skip that one. We'll skip it. Let's go to the next one. I already introduced it. Number 5. We're going to use synthetic division to completely factor the polynomial. So we're going to do division, and then we're going to end up having to factor or solving the rest of the polynomial. So let's start here by doing our synthetic division. What numbers are going to go along the top? We're going to make a sketch of the graph, so we can't sketch it until it's a factored form. So of 1, negative 1, yep, negative 10, negative 8. And what are we trying to see as a root? Negative 1. All right. So go ahead. You can go at your own pace if you'd like, but let's do synthetic division. We bring down the 1. And 1 times negative 1 is negative 1. What do I get when I add those? Negative 2. Good. Multiplying, get a positive 2. Negative 8. Multiply, get positive 8. And it's a good thing we have a remainder of 0, because remember, our goal is said completely factor. So that means it should be a factor, so we should get a remainder of 0. So here's what we have left. After we did division, we get x squared minus 2x minus 8. That's what that polynomial is. Now we're trying to write a factored form here with all those parentheses. We already know, because we got a remainder of 0, that x plus 1 is a factor. We need to find the other factored form by factoring x squared minus 2x minus 8. So you need to figure out what two numbers multiply together to be negative 8 and add to negative 2. Negative 4 and 2. Yeah, so that'll be your factor form, x minus 4, x plus 2. This is, that's from the factor we just checked. So because it divided out with a remainder of 0, it means it is a factor. Right? So technically what we got here by the end of this synthetic division was x plus 1 times x squared minus 2x minus 8. And then we factored it again to get the 3 binomials. Now from there, once it's completely factored, what property of the polynomial can we see really easily? What do the factors give us about the graph? The x-intercepts. What are the x-intercepts here?
-1, 4.
Negative 2. Okay. Now let's use our knowledge from last unit, sketching graphs, multiplicities, and behavior to make a picture of the graph. Alright, so we start by plotting the points. We know there's a root at -1, there's a root at 4, and there's a root at -2. What degree does this polynomial have? 3. So do my arrows go in the same or opposite directions? Opposite. The leading coefficient is positive, so do I start low or high? Low and then high. So I start down here. Do any of them have multiplicity more than 1? No, so I'm going to cut right through the axis at -2, come back down, and then go back up. And there's a sketch of your polynomial. Alright, so you have a little bit of practice here. Not a lot, just a few problems. This is a great day as well to